Welcome to the ninth session of Basics of Remote Sensing. Here we are going to discuss about visual interpretations of remote sensing data. Through this, to identify drainage, rock type, geomorphological and structural features with the help of image interpretation key elements. Myself, Anup VM, Senior Geologist, Photogeology and Remote Sensing Division, Geological Survey of India Training Institute, Hyderabad. Prerequisites for visual image interpretation. For an image interpretation, correlation of geology, drainage, structure and landform informations are combined. With experience, patience and perception, various image recognition elements with proper association and knowledge of climatic environment, knowledge of erosional environment help us for the visual image interpretation. Study of terrain elements are essential in the image interpretation. Through satellite imagery, we can understand about drainage pattern and its density, landform or geomorphological features, land use and land cover pattern, outcrop appearance and distribution, lithological and structural details. Let's start with interpretation of drainage. Drainage pattern. Drainage pattern is the design formed by aggregate of different drainage ways in a particular area. It is an important element in geological interpretations. Depending on the lithological character of the underlying rock, we can identify various drainage patterns on the surface. Arrangement and spacing of lithological and structural weakness encountered by the surface runoff. Different drainage patterns depict various lithological formations. Basic drainage patterns: dendritic, trellis, rectangular, parallel, radial, annular, and internal. These drainage patterns will help us to understand about the lithological formation in that area. Dendritic drainage pattern. The drainage network whose interconnecting streams resemble the pattern of branches connecting to a deciduous tree. When we look at an imagery, we can see the drainage or the streams from the first order to the higher order resemblance like a tree. That's why they are called as dendritic drainage pattern. It indicates the homogeneous, uniform soil and rock material without pronounced structural influence in the area. Trellis drainage pattern is characterized by parallel main channels joined by short parallel gullies occurring at right angles to the parallel main channel. They indicate tilted or interbedded sedimentary rocks. Parallel drainage pattern. These develop where there is a pronounced slope to the surface. Regions of parallel elongate landforms like outcropping, resistant rock bands shows a parallel drainage system. Young coastal plains or large basalt flows are good examples for finding parallel drainage pattern. Radial drainage pattern. They are circular network of channels flowing away from the central high point. Normally, these drainage patterns are associated with volcano or isolated hill dome-like features exhibit this drainage pattern. Annular drainage pattern. They develops on topographical forms similar to radial pattern. Bedrock joints or fractures control these parallel tributaries. Granite or sedimentary domes may develop this type of drainage pattern. Rectangular drainage pattern. Here, streams join each other at right angle because of a rectangular grid of fractures that break up the ground and localize the channel. Internal drainage pattern indicates by abrupt termination in the continuity of the stream course. Drainage density. Very high density and high density drainage indicate difference in porosity of the underlying rock formation. If the spacing between the higher order and the first order streams or within the first order streams, the space between the drainages are less, they are considered as high density drainage. What are the different drainage anomalies? They indicate structural features, change in lithology, or neotectonic activity. Linear drainage cores indicate a fault, major joint, or contact between a soft and hard rocks. If arcuate course is there, it indicates domal structure or closure of a plunging fold. Abrupt changes in density of drainage indicates change in lithology with drastic difference in the permeability of the rock. Abrupt changes in stream development indicates recent tectonic activity and rejuvenation. If numerous stream captures are seen, it also indicates recent tectonic activity and rejuvenation. Linear alignment of sinkholes indicates faults or major joints. Waterfalls indicate fault or change in lithology from hard to soft rocks. In these imageries, we can see the drainage which is flowing in a straight line, or suddenly a course of flow changes happen for the drainage, which is indicating the structural control in that terrain. Through remote sensing data, we can identify these features: alignment or straight line of lakes, water bodies, ultimately give the structural information of that area. I have few questions for you. Question number 1. Drainage resembles pattern of tree branch. Which is that drainage pattern? Options: dendritic, trellis, radial. What is the answer? Option number 1, dendritic. Question number 2. Drainage pattern in an arid limestone terrain. Options: option number 1, annular. Option number 2, angular. What is the answer? Option number 2, angular drainage pattern. Coming to interpretation of rock types. Remote sensing tool is widely used to interpret various rock type. Here we are going to interpret few of those rock types. Here in this chart we can see common igneous rock types based on their mineral composition, texture based on their appearance of mineral grains. It has been classified. All of you are aware about different types of igneous rocks. Let's see through remote sensing how we can interpret igneous rocks. Intrusive igneous rock. The massive character and comparative homogeneity of larger igneous intrusives is reflected in the morphology by coarse and regular dissection, drainage pattern with strong dendritic trends normally, and with a rectangular or angular tendency due to joints. No lineation of vegetation occurs unless pronounced joint exists. Bold topography as well as rock with a resistance to erosion develops rounded appearance in intrusive igneous rocks. Smaller intrusive bodies are best characterized by the form and shapes associated with their mode of occurrence. Dikes appear on the imagery as straight or curved lines or narrow belts. They stretch across the geological features. Many dikes, and especially the acid or intermediate ones, are rather resistant and thus form like a ridge. Basic dikes in humid climates tend to be chemically weak and form depression and exhibit dark gray tone or dark color in a satellite imagery. Image identification elements for granitic rocks. Based on color and tone, granitic rocks generally have light tone due to felsic in composition. Darker tone are visible in depressions which are formed due to joints. Drainage and erosion. Coarse textured dendritic pattern with a tendency for streams to curve around base of the dome-like hills are visible in granitic terrain. Secondary drainage channels may form along joints. Generally, granitic terrain are occurred with variable summit elevations. Comparison of granite and sandstone terrain. The principal difference between two are as follows. Evidence of bedding absent in granites, whereas sandstones are bedded. Topography-wise, granitic terrain, variable summit elevations are visible. In sandstone, it forms like a flat plateauic terrain. Granitic rocks, they form rounded cliffs, whereas sandstone terrain we can identify vertical cliffs. Micro features are rounded in granites, whereas blocky in sandstone. Joint pattern. Granitic rocks have an irregular joint pattern with some distinct linear depressions, whereas sandstone has a joint system consisting of 2 or 3 principal directions. Here we can see the imagery of a igneous terrain, granitic, and a sedimentary terrain of sandstone. Whatever the comparisons we have discussed in the previous slide, we can relate over here from this imagery. Extrusive igneous rocks. Image identification elements of flood basalts. Phototone and vegetation. Basically, they have dark tone along valley walls. Topography-wise, nearly level surface, often cut by major streams that form deep valleys. Sometimes they are found as high plateaus. Drainage. Parallel and internal drainages are common in such terrain. Convergence of evidence for intrusive igneous rocks. Acid intrusives. They generally have light tone, coarse texture, lack of stratifications. Features like tores are visible from the satellite imagery. They have varying density of drainage, better orientation due to joints. Dendritic and rectilinear drainage due to joints are visible. Outstanding ridge due to fault. Vegetation variable and normally less dense. Whereas in basic intrusive dikes, darker tone and medium texture is visible, form as a linear ridge or depressions. A sudden contrast in image or photo characters of any lithological unit can be identified. Convergence of evidence for extrusive igneous rocks. Basic extrusives forms volcanic features like cone, plug, craters. Step features of successive flows are visible and interpretable from a satellite imagery. Radial drainage, active erosion and weathering surfaces are visualized from a satellite imagery. They are of varied tone. Vegetations are sparse in arid and luxuriant in humid climatic conditions. In the contrast, motile texture, they are forming with varied tone. Internal, parallel and dendritic drainages are visible. Layered and step-like hill slopes are also identified using satellite imagery. As a landform, mesa, butte and plateaus are also the contrast conditions. Image interpretation of sedimentary rocks. Characteristic features of sedimentary rock is that they are stratified owing to various conditions of deposition. As a result, they typically display banded appearance on photograph and satellite imagery, although the width of bands depend on the attitude as well as thickness of individual strata. Topographic expression of sediments depends on attitude of bedding horizontal to vertical as well as on resistance to erosion, which are controlled by compaction and cementation, porosity and permeability, bedding thickness, rock composition, and hydraulic action in that area. Let's discuss about bedded sandstone features. Topography-wise, they are of bold, massive, flat-top hills of equal elevation. Nearly vertical hillsides are visible from the satellite imagery. Normally, coarse textured, joint controlled, modified dendritic drainage pattern as well as rectangular drainage patterns are also visible. Erosion wise, gullies and V-shaped valleys are formed. Tone or color wise, light color of the rock is visible. In some conditions, they give darker tone based on the vegetation, commonly forested in humid and wildly sparse in arid climatic condition. These are some of the imageries showing the bedded sandstone terrain. As we discussed in the earlier slide, we can see the characters of a sandstone terrain. Coming to shale, topography wise, minutely dissected with steep stream or gully in arid climatic conditions, they form gently to moderately sloping, softly rounded valleys and hills. Drainage, fine textured, trellis or rectangular or dendritic pattern with gently curving streams in arid climatic condition. Medium to fine textures in humid climatic condition. Erosion wise, sharp angular in arid terrain. Gullies have gently rounded cross sections in humid conditions. Tone wise, generally darker tone. Vegetation, intensely cultivated in humid conditions. These are some of the satellite aerial photographs showing the shale exposure. Here, the trellis drainage pattern is visible. Densely vegetated and cultivated terrain is visible from this imagery. Limestone, topography wise, karst topography in humid conditions and they form table rocks in arid climatic conditions. Mostly internal drainage as well as angular drainage is visible on a limestone terrain. Phototone normally light to dark depending on the cover. Vegetation mostly barren in arid conditions and vegetation if the soil cover with clay formations are there is visible. Here we can see the karst topography as well as sinkholes and depressions with internal drainage pattern. This is a condition in a humid climatic terrain. In an arid climatic conditions, mostly they form as a cap or table rocks with angular drainage pattern, which is very much visible from the imagery. These are the aerial photographs showing sinkholes in limestone. This is a consolidated table for the interpretation of various sedimentary rocks based on topography, drainage, tone, gullies, vegetation as well as land use. Image interpretation of metamorphic rocks. Common metamorphic rocks. Metamorphic rocks commonly are grouped by texture and composition. The characteristics minerals, parent rock and composition of both foliated and non-foliated rocks are included in the chart below. Tonal anomalies offer the best clue to recognize bedding in metasedimentary rocks. Thick horizons of quartzite and marble might readily retain the photographic characteristics of the original sedimentary beds. The presence of metamorphic rocks is discernible through a number of widely spaced linear tonal anomalies at the right angle to the regional trend. These linears commonly represent regional cross joints. They may be reflected as abrupt reflections of drainage along otherwise straight stream courses or as a development of new tributary streams through the satellite imagery. Texture of the rock changes with increasing grade of metamorphism. Here we can see the sequence of foliated metamorphic rocks produced by shale is given below. Different grade of metamorphism and the image characteristics are visible from shale to slate, schist and gneiss. Here we can see in a table about different metamorphic rock types, their key elements of identification through topography, drainage, tone, gullies and vegetation. Each rock types from their parent origin, we can relate the key element characteristics. This is a part of peninsular gneissic complex. We can see the image characteristics of metamorphic rocks. I have few more questions for you. Question number 1. Bold, massive, flat top hills of equal elevation are the characteristic terrain feature in options. Option number 1 granites, option number 2 sandstone, option number 3 limestone. What is the answer? Option number 1 sandstone. Question number 2. Intense vegetation, dark tone and trellis drainage pattern characteristically for options. Option number 1 sandstone, option number 2 shale. What is the answer? Option number 2 shale. Interpretation of structure. Remote sensing is used as a tool to extract information about the land surface structures. Structural geology play an important role in mineral and hydrocarbon exploration and to identify potential hazard identification and monitoring also. Elements of interpretation for structures. Identification and characterization of structural expression, fault, fold, joints and lineaments are done using different satellite imagery of various resolution. Straight line segments of stream courses, alignment of lakes or water bodies, streams and vegetation are widely used to interpret the structural anomaly from a satellite imagery. Sudden change in photographic tone, anomaly of drainage, textural difference, presence of linear features are some of the characteristic features to identify structure from a remote sensing data. Drainage characteristics may also aid in recognizing and delineating the folded structures. Stream flowing in a synclinal valley are mostly sluggish and meandering, which is identifiable from a satellite imagery. Here are some of the satellite imagery showing various structural features which can be easily identified from the data. Faults, folds, joints and lineaments are very much interpretable using different resolutions of satellite imagery by visualization as well as by digital image processing. Interpretation of landforms. Landform features are identified using various satellite imageries. Denudational landforms, which are involving highly dissected denudational hills, moderately dissected denudational hills, plateau ridge valley complex, Piedmont slope, colluvial fans, gorges, ridges, Q-star are clearly identified using satellite imagery. Fluvial morphological features, paleochannels, coastal morphological features like barrier island, lagoon, longitudinal bars, offshore bars, spits are clearly visible through the satellite imagery. Aeolian landforms like dune complex and various glacier morphology are interpreted using satellite imagery. Landforms can be interpreted using digital elevation model. Various DEM-derived maps can be prepared like contour map,
hillshade map, slope map, aspect map, which will be helping to finalize a geomorphology or landform maps.
So the image interpretation is a combination of analyzing the imagery based on the key elements of interpretation as well as by the help of computer aided techniques using digital image processing. A person or an image analyst uses both these techniques effectively in order to identify various features or processes on our Earth surface through remote sensing data. Thank you for watching. This is the end of the current session, and the next session is on applications of remote sensing.